Guys, now we want to see how to calculate velocity and distance when we are dealing with integration. So you can see the story looks a bit long, but it shouldn't frighten you. All you need to know is that integration is doing the reverse of what differentiation was doing. So differentiation, you differentiate distance to go to acceleration, to velocity, differentiate velocity to go to acceleration. So now if you are returning, you integrate acceleration, it takes you to velocity, then velocity to distance. So now let's look at this simple problem. It says the velocity of an object, the velocity equation of an object is given as v equal to 3t plus 5. We need to determine the distance traveled during the third second. You are advised to apply integration to solve the problem, and you are also told that area below a velocity time gives you distance. So the only unfortunate thing with level 4 is that they don't give you formulas for this, but if you are versed with what is happening, you know that distance is the integral of the velocity with respect to time. And because you are told to calculate the distance in the third minute, it means you must start from the 0 minute to the third second. So it will be a definite integral from t1 to t2. So here, our velocity equation goes there, which is 3t plus 5, and we're calculating the distance in the third second. So you must start from somewhere, which is obviously the 0 second up to the third second. So that is how simple it is. Then you start applying your normal rules of integration. There are two terms here, so I need the integral sign 2 times, all from 0 to 3, 0 to 3. Here our variable is now t, so anything that is not t is a constant. It goes out, the variable stays in, the constant goes out, the variable stays in. So if I'm integrating that, I will get 3t squared over 2 according to formula 20 for maths 24. Then the integral of that is simplified t, since we're integrating to t. So there will be no plus c because we have a limit from 0 to 3. Then we switch over to formula 29, which says you substitute the upper limit first. So that will be 3 into 3 squared over 2 plus 5 into 3, that's my upper limit, then minus the lower limit, which I'm replacing every t by a 0. Here. So the lower limit is obviously 0, 3 squared over 9, 9 times 2, 9 times 3 is 27 over 2, then this one is 15. So it's just for you now to use your calculator. 27 over 2 is like 13,5. 13 plus 15 is 28,5. So that is your distance. You can also use your calculator to put it in fractions. So that's how simple it is to calculate your distance covered in the third minute for an object that is moving with a velocity of 3t plus 5. So also switch over here and look at one problem that is asking us to calculate the velocity. So now if we are determining the velocity, it means the acceleration equation must be given to you. So we're told that the acceleration equation of an object is given as a equal to 2 over t, where t is time in seconds and a is the acceleration. Determine the average velocity of the object between t equal to 1 to t equal to 4. So you see it's again, by means of integration, it's again the definite integral. So now if I'm looking for velocity, I have to integrate the acceleration from t1 to t2. So the acceleration equation is given to us here as 2 over t. So I'll get my 2 over, the integral of 2 over t equal to 1, that's lower limit, t equal to 4, that's upper limit, to t. So this is a perfect match for formula 23 in your formula sheet, which gives us 2 in t from 1 to 4. So here you substitute your upper limit, you get the ln of 4, that's your upper limit, guess with this one you can complete. It's just a matter of using a calculator. Unfortunately, I don't have a calculator here, but that is the main part. You just know that the formula for velocity is the integral of acceleration dt. You put the acceleration equation, it's right there. So you put 2 over t from t equal to 1 to 4. So when I'm integrating 2 over t, it gives me 2 dt. Then I substitute my upper limit in the place of t first, it's a 4, minus and substitute the lower limit, it's a 1. So from here, you're going to get to your answer when you touch your calculator. Let's take that one as homework to do the calculator part. Thank you very much.